Hello there, here's a help file for the question where you have a velocity of a canoe relative to the Earth and the velocity of the river relative to the Earth as shown in this diagram. So we have the canoe relative to the river as 0.43 meters per second at 45 degrees to the horizontal, and then the river is flowing east at 0.56 meters per second. Find the speed of the boat, of the canoe, relative to the river. Remember the example where if you have a boat going like this and the river going like that, you end up with your total. So if this is velocity of the boat relative to Earth and this is velocity of the river relative to Earth, then you end up with your velocity as the addition of the two vectors. Here I wrote it out as velocity of the canoe relative to river plus velocity of the river relative to the Earth gives us the velocity of the canoe relative to Earth. So then, since we have the addition and we need the canoe relative to the river, we need to subtract. To get velocity of the canoe relative to the river, we need to get velocity of the canoe relative to Earth minus velocity of the river relative to Earth. See how I'm going after this? And I need to subtract this from here. And remember, when we subtract, we can do a fork, which is what we have right now. If I do a fork, remember the left smiley face. So I'm going to connect velocity of the river relative to Earth to the velocity of the canoe relative to Earth. So that's what I'm after. And to do that, I'm going to write out the components of both of them, the x and y components, and subtract. So there we go, your components. So for the canoe relative to Earth, you have the x is positive, but the y is dipping down, so it's negative. For the river relative to Earth, no y component because it's strictly horizontal going east. When you subtract 0.536 from, comes out to be 0.304 with the cosine of 45. You subtract that and you get your negative 256, and then vertically you just have that negative 304. So as you can see, here's your velocity of the canoe relative to river, and it has both components negative. So when you do Pythag, you end up with this value right here, 0.397 meters per second. That's a lot of work. You could have used law of cosines and could have gotten the same value. So you have this angle. So then you just take this is your A, that's your B. You do the squares, and then you subtract the double of the product of those two with the cosine of the angle between them, and that would give you the 0.397. However, when they ask you for the direction, which is this angle right here, you would still need to have the components. That would be the easiest way. Or you could have done the law of cosines backwards. That's too much math for me. If you do that, that's going to be the 49.9 against the current, and because they give us 3 sig figs, it's 49.9. That's the canoe and the river. On to more helpful files later.